Okay, so this section of the course is it's going to be looking at how we can learn about the past climate and I guess local oceanographic conditions from corals. So I guess you might want to, I guess first of all, maybe take a step back and ask about why we might want to do this when we already know so much about our planet from kind of direct observations. So I mean, here's a satellite image, right? If I get a swath of different satellite images all brought together, and you can quite clearly see some hurricanes making their way across the Atlantic Ocean. I guess you can make out some features here. So here's Cuba, Florida, and Africa, which is of course not a country, a continent. And you've got your hurricanes kind of making their way. Here's a little hurricane here doing its thing, making its way across the Atlantic. And the colours that you can see behind, so these blue tracks here following these hurricanes. These are measurements of the sea surface temperature made from satellites. So we can see here that that's the water gets churned up by the hurricanes. That's bringing cold water to the surface, and we can see some kind of influence of the atmosphere and ocean interactions. So we can learn a huge amount about how our planet works and how it's changing from direct measurements. Here are some other, I guess, examples. So we currently have a network of these Argo floats. So these floats are basically jettisoned off ships or aircraft, and they float around in the ocean. They kind of sink down to some predetermined depth in the ocean. They drift around for a while, pop up to the surface, and as they do that, they're constantly recording the temperature and salinity of the water. Some of them also have other optical sensors on them, measuring kind of the light penetration into the ocean. So this gives us a huge amount of information about the depth profiles of physical properties, temperature, salinity. Because they drift around, they also tell us about ocean currents. I already mentioned we get a huge amount of information from satellites. So the present ocean is actually remarkably well instrumented. We know a huge amount of what's going on at the moment. But if we look kind of back in time, so this is a graph of basically showing us how much data is collected in the ocean or from the ocean from direct I guess, observations. So these are things where an object, some kind of sensor, is going into the ocean, and that can be a thermometer or conductivity sensor, or someone is scooping up a bit of the ocean and then measuring that. And you can see how that's changed through the years. I guess this compilation only up to 2014, but you can see in the kind of the 1750s, we were only maybe getting 1,000 observations of the ocean a year, and these largely came from ships recording the temperature of the water, maybe wind direction or pressure, as they kind of sailed around the ocean. And as the kind of the density of shipping has gone up, the number of observations has steadily increased through time. I should point out that this is a logarithmic axis, so this straight line on this graph would be an exponential increase in the density of observations. So just to point out that all the coloured kind of lines on here are all the different types of observation or the types of measuring platform. So the black line at the top is the total, and the grey line, which is kind of here, that's kind of measurements from ships. And you can see what's quite interesting is that through the whole kind of I guess history of oceanographic measurements from the 1750s up until I guess the 1990s, the vast majority of measurements were measurements of ships, people going out and making measurements. But you can see here, since I guess the mid 90s, at this point here, we can see that these two other sources have overtaken the ships as the most abundant data source, and that are these drifting buoys. Oh, that's an unnecessarily unstraight line. These drifting buoys here. So these are those Argo floats, and also buoys which are kind of like fixed in position. in the ocean, constantly kind of measuring at any one locality. So ships, going out on ships is still important, but the vast amount of data we're getting from autonomous platforms at the moment. That high density of data, you can see, only really goes back a few decades or so. So what we can see from this is that although the amount of measurements we're getting from the ocean is quite large, tens of millions of measurements per year, those data don't go back very far in time in that kind of density. As we go back 100 years or so to the beginning of the 20th century, we're down to maybe hundreds of thousands of measurements per year rather than the millions. We can also see that the range of measurements that have been made, so rather than looking at the platforms that they were measured from, so predominantly we can see here that actually because the data density is lower as we go back in time. If we look at the amount of ocean that's actually been sampled back in kind of the 19th century here, I guess we're looking at less than 1% of the ocean has been measured, so we know very little about the ocean that far back in time. It's looking quite good. Over 50% of the ocean measured. I guess now we know about that, but we're really limited to some, I guess, easy to measure parameters. So things like sea surface temperature, pressure, the air temperature. So these are really measurements that were made for the purposes of meteorology, so to understand kind of the weather rather than to understand the ocean. So we're quite limited with the range of measurements that have been measured back in time, as it were. And just to kind of like hammer home that spatial distribution of measurements, so we were really limited to where, I guess, people were going in ships that had thermometers on them. So you can see that in the 2000s, even in the 1970s, the ocean is quite well covered in terms of its measurements of sea surface temperature. But back into the 19th century, huge parts of the Pacific Ocean here, I mean, not really measured that well. The Southern Ocean, not really measured at all. Not really that we're going to be able to fill in that gap in the Southern Ocean with corals. There's not that many sea surface dwelling corals that live in the Southern Ocean. But there are large parts of the ocean which we basically don't know about or don't know kind of how their oceanographic conditions were back in time, even only 100 or so years ago. So another potential way that we can maybe get around this problem is by using some of this meteorological data that's actually that's been collected for a reasonably long time in terms of, I guess, the industrialization of the planet, but maybe not geologically a long time ago when people, mostly from, I guess, Asia and Western Europe started to make meteorological measurements. So we're looking at maybe going back hundreds of years. We can use measurements of particularly things like atmospheric temperature and pressure, because those parameters in some situations can quite closely correlate with the oceanographic conditions back in time. So this is an example which I guess may be familiar from the brief introduction to the El Nino Southern Oscillation. So if we wanted to know what the temperature of the ocean in this box here was back in time, we don't really have that many measurements going back hundreds of years of anything going back there, because we weren't there measuring the temperature. But what we can do is if we measure the sea level pressure in Darwin and Tahiti, and there have been meteorological stations these two locations for many years now, we can see that the sea level pressure here, so that's pressure here, that quite closely correlates with the ocean temperature in this box. So we can use, I guess, indirect, direct, I guess, real measurements, but indirect measurements of the ocean to understand about how the ocean has changed in the past. But I guess this is, a step removed from actually measuring the ocean. So this is, an example of exactly that. So we actually have a record of this pressure difference going back, I guess, almost 150 years now, giving us quite a long record of the, I guess, the state of the ENSO, the El Nino Southern Oscillation system, which is quite neat. But we can't do this for all parts of the ocean, and we can't do this, I guess, further back in time from when, I guess, Europeans started to come to these places and build meteorological stations, amongst other things that they did there. So this is where we start to go into the paleoclimate proxy kind of world. So this is an example, I guess, from the terrestrial realm, where scientists have used tree rings. So tree rings are very useful because they're very easy to count. So we can work out exactly how old a particular ring in a tree was. So we can basically count back the rings and get the age. And then we can use the thickness of the ring to tell us something about the climate in which that tree grew. So if it's a particularly thick ring, that might indicate a warm or wet or very productive growing year, whereas if it was a very thin ring, that might indicate a colder, less suited for tree growth. We can build big compilations of these, and we can use that to reconstruct the regional temperature, right, where that tree grew back in time. And this is effectively what's been done to work out the surface temperature of the planet back, I guess, almost, I guess this is a compilation that only goes back 1,200 years, but I think we've gone back for 2,000 years to illustrate like how variable the climate has been over, I guess, the last 1,000 years, and how anomalous the warming at present is. So we can use, I guess, what we would call proxy measurements, where we're measuring some kind of thing that occurs in some kind of medium. In this case, we're measuring the thing is the thickness of the rings in the tree, and that tree is the medium. And that we're using as a proxy for the local environmental conditions. So we are going to look at a variety of different proxies throughout the rest of this kind of section of videos. So we're looking into the past because we can extend that instrumental record. We can look further back in time to get a longer time series, which will allow us to really say, you know, whether a particular climate phenomenon is anomalous or not. It might allow us to see different kind of climate behaviors which we've not yet observed in the instrumental record. We can also use this where there aren't any instrumental records because for whatever reason Europeans with weather stations didn't rock up and record all of the information. So we're basically using these proxies of past environmental conditions as data logs. And the image I've got up here is this guy Charles Lyell, who was I guess Edinburgh scientist, and one of his I guess his key ideas in the Scottish Enlightenment was that you could use the present environmental conditions to understand kind of like rocks and the past, but actually we can use that obviously the other way around, and we can use the past kind of, I guess, rocks. Corals are rocks, of course, to learn about how the Earth works. So yeah, so just to get some dictionary definition of proxy is, so you might have heard the word used as, I guess, in a variety of different settings in terms of someone that acts on behalf of another person in terms of maybe proxy voting, or maybe kind of a political proxy actor or something like that. But actually, we're adding in this kind of additional term. So it's a measurement of a physical object that we can kind of extract from the geological record, something that we can measure in that to reconstruct an environmental parameter. And that could be temperature, salinity, or a variety of other things. So just to give some examples, and we'll go through these kind of in separate videos into how these work and some examples that are being used. So for example, we could want to reconstruct the temperature in which a coral grew, and we might use its isotopic composition of oxygen preserved in its skeleton, or the proportion of strontium compared to calcium. in the mineral structure. We might want to reconstruct how acidic the ocean was. There are a variety of different kind of physical properties of corals, but also chemical and isotopic measurements that we can make in those. So we'll go over each of these kind of in turn, but basically the summary of this introduction is that using kind of paleoclimate, using proxy measurements of the past ocean conditions in fossil corals is really useful because it allows us to extend our knowledge of the ocean back in time to times when we didn't have kind of a wealth of data that we have from direct measurements. And it also allows us to go and sample spatially exactly where in a region that we want or we're interested in without there having to be a weather station that has existed there for many hundreds of years. Right, we'll stop there, and the next kind of few videos will go through each of these different systems, how they work, and some examples of I guess them working. So yeah, that's us done for this video. Fun times.